Alrighty, so we're on page 75. This is going to be circles and similarity. Now, so if something is similar, it has the same shape, right?
Yes.
But different sizes. If something is congruent, they're both the same size and shape. But right now we're just talking about similar. So, are all circles always going to be similar?
Yes.
Yeah, they're all the same shape, right? Okay, so they're all going to be the same shape. So they're all going to be similar. So can I say all rectangles are going to be similar? No, because they could be different lengths and different widths, right? And they're not going to be similar to each other. Squares.
No.
Would those always be similar?
Yes.
Yes, they're going to be the same. They're always going to be similar. Because all four sides are the same. All four sides, right, are in ratio, and all the angles are going to be the same. So it's going to be the same shape, but different sizes. So squares could be in the same category as this. So they're always going to be similar. So it says draw a circle with the radius 2, center located at 3, 3. All right, let's see. Let's go 3, 3. 1, 2, 3. 1, 2, 3. The radius is going to be 2, so I'm going to go out 2 units, right 2 units, up 2 units, and down 2 units.
Just 2?
Yeah, because it says a radius of 2, right? I'm doing my best to try to... There we go. All right, not bad. So label this one A. So I'm going to call this one A. That one is circle A. Perform a dilation on the circle and its center with a scale factor of 3 and label it B. Okay? On the circle and its center. All right. What is the radius of this going to be if it now has a scale factor of what? Above 3, right? What am I going to do to the radius? I'm going to do what? Multiply by 3. So what's going to be the radius of the new circle? It's going to be 6, right? Okay, so now, and we're going to dilate it. We're dilating the center also. So where's the center of this now going to be at?
6, 6.
Oh, ouch. What's 3 times 3?
9.
So it's going to be 9, 9, right? So 9, 9. It's going to put me right here. Okay, this is going to be B.
Is the radius still 2?
Nope. We dilated it, right? Dilate it, so this one's going to be bigger, right?
So 6.
It's going to be whatever the radius is, which is 2, times the scale factor of 3, right? So it is going to be 6. So let's go ahead and I'm going to go out 6. 1, 2, 3, 4, 5, 6. There's an edge. 1, 2, 3, 4, 5, 6. There's another edge. 1, 2, 3. 1, 2, 3, 4, 5. There we go. All right, so, all right, for mine, because I'm trying to make mine a good example for you guys, so I'm going to use my stabby thing here. Wait, where's my stabby thing? Someone took my good stabby. I'll use this one. Okay, so go ahead, try and draw your circle. Try your best. Alright, so let's see if I can actually get this one to be a decent circle.
Is that anybody over there?
Ah, dang it. You can't get it. Why is the radius 6? What was the radius of my first one? 2. The radius of my first one was 2, wasn't it? Okay, and at my scale factor, what did I multiply everything by? 3. So if the radius is 2, now it's going to be 3. I'm looking for my screwdriver. So it's 3 times 2 is going to give you your 6. Not really. I'm trying, but all my compasses are either broken or stolen, or all my good ones are stolen. People use it to like stab each other.
I was thinking about long necks and Tyrannosaurus Rex.
Okay. All right, you guys. So hopefully your guys' is going to be even better than mine, right?
Sure. Whatever you say.
No. Glad you finally started addressing me properly.
Are you gonna be using the things again?
No. They were all stolen, so all the good ones are gone.
Okay, so we'll have to.
Just do your best.
You have to. What's called? Refer to me as chinchilla.
Are you chinchillin?
Yes.
Okay. All right. So I'm going to try my best here. Ah, there we go. Okay. So
Oh, that's nice. I'm upset.
there we go.
I'm actually upset.
So I'm going to try and trace this out. Let's see, so you guys can see this. And we have most people that are off task, just over there talking about everything else. And no one's even caring to try and do their work. Or... Ah, there we go. All right. A good looking circle, right? So, let's take a look now.
Oh wow, that's a good circle.
Okay.
My shit ugly.
Agreed. All right, so listen, please. Now I got everyone's attention up here. So it says, this is B. What is the center of the circle dilated? The center was where? 990. What was the radius? 6. What's the ratio between the radii of circle B and circle A? So what's the radius of circle B? 6. Oh, I wrote
What
9.
Is that it? That's it?
That's 6. Hey, shh, please. What was the radius of the other one? 2. So it's 6 over 2. How does that relate to the scale factor? What is 6 over 2?
3.
So 3 is equal to 3, right? So when I do the ratio of the second one to the first one, it's always going to give me the same scale factor. Find the circumference of each circle. Now, do you guys recall, what is circumference?
It's like perimeter.
It's perimeter around the outside, right? It's all the pizza crust.
So is it pi times radius?
Pi times 2 radius, or pi times diameter. So circumference is equal to
Pi.
2 pi r.
Can we just put pi times diameter?
Yeah, you can, but I'm going to put up the formula 2 pi r. Because we're using the radius in all these, right?
Oh.
All right, so I'm not going to approximate this on the calculator because the math comes out a whole lot easier if you leave it in terms of pi. So let's take a look. Circle A, my radius is what?
3. It's 2.
2. Circle A was 2, right? So it's going to be 2 times 2 is, so it's going to be 4 pi is my circumference. 4 pi is the circumference. So that's in terms of pi. So as long as we're not just sitting there drawing on our hands and actually trying to take notes, we might get this. So, chinchillin. All right, so now let's do the next one here.
Chinchilla. Please refer to me correctly.
Okay, on this one right here, what was the radius of circle B?
6.
So it's going to be 6 times 2 is?
12.
It's 12 pi. All right, what is the ratio of circumference B to circumference A? 12 pi over 4 pi. And if I reduce those, pi's cancel. What's 12 divided by 4?
3.
It's going to give me 3, isn't it? So is that the same scale factor? Yeah, it is. It's going to be the same scale factor. Now, area. Area is equal to pi
Radius squared.
r squared. Very good. So we're going to leave this one also in terms of pi.
Is pi radius squared?
Yes, pi r squared. Now, circle A. We said that the radius of circle A was what?
4. Or it's 2.
2. So watch this. So 2 squared is 4 times pi. So it's just going to give me 4 pi.
Wow.
Now the next one, circle B. Circle B.
It's 6.
The radius is 6, right? 6 squared is,
36.
so this is going to be 36 pi.
Is he-
Wait, okay, Mr. Patrick, can you explain B?
What?
Can you explain B?
What part of
Why is
B?
it 36?
What's the radius?
The radius is 6.
Okay, so and the form.
Sorry, never mind, sorry.
There we go. All right, says what is the ratio of B to area A? So now let's do the math. So it said B to A, so it's 36 pi divided by 4 pi, which gives me
20.
9.
She's not 20.
Now, you'll see this here in a minute and why this works out like this. It's not going to be the same as a scale factor because area is two-dimensional. It's a length times width. That's the reason why I always say area is going to be always squared. So the units are squared. So all the time when we're doing this, you're always going to have the unit squared. Girl, come on. Okay. No, you're not. No, we're down over here. I know. He's the one that told us he didn't want to do any work. Okay, let's take a look. Is there transformation? Listen, please. Is there transformation that will map circle A onto circle B? Now, how can I move it from A onto B? It's going to be a dilation, right? And what else?
Multiplication.
What else? I got to move it, right? Translation, right? So watch this. So I'm going to do two things.
But Miss, isn't it just a dilation of scale factor 3?
No. That's actually dilating it from here. But now we're going to do it as a transformation. So now, remember, transformations are moving. So are we going to reflect it, translate it, or
But isn't
rotate? Yeah.
Isn't dilation a transformation?
Yes, it is one that, and that's what it is. So it's going to be a dilation, right? But what we did here is we actually did it from this point here. Now I'm trying to move it from here to here. That's what it's asking. To move it from A onto B, what would I do? I would do Okay, X, comma, Y. Now, do you remember this?
Yeah, I didn't like the X.
Are we moving to the right?
Yes.
How much are we moving to the right?
2.
We're going from A to B, right?
Oh, yeah.
1, 2, 3, 4, 5, 6. So what would I write?
X plus 6.
X plus 6, comma. And that's to there, right? Now what am I doing to my Y value? Up how much?
6.
6. So I'm going to write
Y plus 6.
Y plus 6. And now, so there's how we did that one. That's moving A onto B, right? So the next thing I have to do is what? Dilate it. So it's going to be dilate it. Yes, dilate by 3. So it's going to be dilated by 3. Now, are the two circles similar?
Yes.
Yes. Here's the test answer. All circles are similar. There we go. All circles.
How do you know?
Okay. All circles have the same shape, right? If they are not a circle shape, then it's not a circle, right?
Sebastian disagrees.
No, I don't.
CC videos.
I agree.
I have no clue.
All circles are going to be similar, right? They're just same shape, different sizes. Can you please stop? That's like number 10. Aren't you like taking notes now of how many times she says it?
I've lost count.
I know. Me too. This next one says circle O has a center of 0, 0 with a radius 1. Please draw that. Go ahead, go.
Circle O has a center.
Please draw that right now.
0, 0.
Everyone. That means pick up your pencil. Draw a circle. Centered where?
0, 0.
What is my radius?
1.
Please put that in there.
Circle P.
This is my candy getting next.
So I was,
I'm proud of
this is gonna be in the middle.
Yeah. So here,
Radius of 2.
there's that one, right? Says circle P has a center of 2, 1. Right, 2, up 1, radius of 2. So it's going to go here, 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 and here. There you go. Oh, that one's a horrible part.
It's gonna collide.
Yep. Did you put your 2 circles in? Did you graph them? All right, let's look. Describe the transformation that will map O onto P. So if I'm starting at O, what do I do to get to B? Or get to P?
Translation and dilation.
Translation and dilation. So you're saying it's going to be X comma Y is moving what?
X plus 2.
X plus 2 because it's to the right. And then
Y plus 1.
then dilation, right? Are the 2 circles similar?
Yes.
Why?
All circles are similar.
All circles are similar. All circles are dumb. Which one?
No, he wasn't playing. You serious? All the circles are
Similar. Okay, the next question says, circle M has a center of 2, -3 with a radius of 2 units. Circle N has a center at -2, 1. The radius of 3 units. Describe the transformation. I'll put M onto N. Okay, it's going to be a translation and dilation, right? Alright, so how am I going to do that? X comma Y. So, if it's starting here, right? And it ends up over here, what did it do? -4. It subtracted 4. So 2 minus 4 gives you -2, doesn't it? Okay. So X minus 4. Now the Y values. If I start at -3 and go to 1, it's going to add 4, right? Alright, so now it's the dilation. Now, how was I able to figure out the scale factor earlier? When I did it on that first question. I compared something to get my dilation.
You divided.
You did like the ratio thing.
Yes, I did the ratios. What I did the ratio of.
Of
The
3. 2 over
radius?
3.
So which one goes first? Which one's on top?
2. Which was max? 3.
Okay, look at the top problem, please. Look at the top problem. How do we figure out the scale factors? It's the second one divided by the first one, right? It's the second one divided by the first one. The second one divided by the first one.
First radius.
So my first radius was 2, right? And then the second radius is 3. So it's dilation of, it should be 3 over 2. Because it's the second one, which is a radius of 3, over your first one, which was a radius of 2.
Yes, sir.
Are all circles similar?
Yes.
Now, can you explain why? I think I've said it 3 times.
Because it's the same shape.
All circles are similar.
They are all similar, but why? Same shape, but
Different size.
different sizes. So go ahead and add that in. Let's see who's paying attention to that one.
Just different one.
What was it?
Different sizes.
Yeah. Did you get it? Alright, so let's take a look at 74. Looking at 74, it's a lot of the exact same that we just did right there.